Hi children, in the last class we discussed about the graphs. There are two types of graphs. They are distance time graph and velocity time graph. In the last class we discussed about the distance time graph. Today we are going to study about velocity time graph. What is velocity time graph? Or otherwise we can say it as speed time graph. Speed time graph. Okay, velocity time graph or speed time graph. How can we represent the velocity time graph? We know the velocity time graph is a relation between the velocity and time, and the speed time graph also is the relationship between speed and time. We are already studied how to draw a graph. We know there are two axes, x-axis and y-axis for any graph. For any graph there are two axes, that is x-axis and y-axis. First we can draw the x-axis and y-axis. This is the x-axis and this is the y-axis. For the velocity time graph, we take time in x-axis. In the distance time graph also we take the time in the x-axis. Okay, the time in seconds. Okay, then the velocity is represented in the y-axis, that is velocity. Velocity is, the unit of velocity is meter per second. Okay, and the origin is here. In the distance time graph, we take distance in the y-axis. In the velocity time graph, we take velocity in the y-axis. Hope you understand that. Then we can draw a graph based on this data. So we can draw the graph, a velocity time graph based on this data. Okay. First, the velocity, in the velocity time graph, it is 0, 0. The time is 0. At 0 second, the velocity is 0 meter per second. At 1 second, the velocity is 2 meter per second. At 2 second, it is 6 meter per second velocity. Okay, and so on. The time 0, 1, 2, 3, 4, 5, 6. So we can take the time as 0, 1, 2, 3, 4, 5, 6, 7, 8. It's enough. Then velocity 0, 2, 6, 10, 12, 20, 22. So we can take here velocity as 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. This enough. Okay. Then we can mark the points. At 0 second it is 0. Okay. At 1 second it is 2. At 1 second it is 2. The point will be here. At 2 second it is 6 meter per second. At 2 second it is 6 meter per second. Okay. Then at 3 second it is 10 meter per second. At 3 second it is 10 meter per second. Okay. 3 second 10 meter per second. Then 4 second 12 meter per second. 4 seconds 12 meter per second. It is here. Then at 5 second it is 20 meter per second. At 5 second 20, it is here. Okay, then at 6 second it is 22. At 6 second it is 22 meter per second. The velocity is 22 meter per second. Then we can join these points. This graph is same as that of the distance time graph, there is only one change, that is in the place of distance it is velocity. Okay, so this is our graph. This is the velocity time graph for the given data. The scale. Okay, how can we write the scale here? Here for x-axis. For x-axis, the time for 1 centimeter, it is 1 second. Okay, 1 centimeter is equal to 1 second. And for y-axis, it is 1 centimeter is equal to 1 centimeter is equal to 2. There is the difference of 2 between any 1 centimeter lines. That is 1 centimeter is equal to 2 meter per second. This is the scale. Okay. Here, this is the velocity time graph. Okay. There are two important things. You have to notice the two important things. That is, by using this graph, we can calculate distance. By using velocity time graph, we can calculate the distance. We can calculate the distance from this. The distance traveled. The distance traveled for this VT graph, velocity time graph, is the area under the graph. This is our graph, and the area under this graph gives the distance. This area gives the distance of this velocity time graph. For this velocity time graph, the distance can be calculated from the velocity time graph. That is, the area under this graph is the velocity time graph. Okay, so the distance is equal to area under velocity time graph. Okay, hope you understand. Then in the distance time graph, we said that the slope of the distance time graph is velocity. The slope of the distance time graph gives the velocity, isn't it? We have studied it in the previous class. So, what is the slope of velocity time graph? Okay, we can calculate the slope of velocity time graph. Slope of velocity time graph is equal to, we know slope is equal to y2 minus y1 by x2 minus x1. Okay, slope is the y2 minus y1 by x2 minus x1. Here in y-axis, we take the velocity. Here y2 and here y1 and y2 are the 2 points, or any 2 points in the y-axis. Here in the y-axis, we take the velocity. So we can take any 2 points of velocity, that is v2 minus v1, and x2 minus x1, that is x1 and x2 are the 2 points in the x-axis corresponding to the y1 and y2. x1 is corresponding to y1 and x2 is corresponding to y2. That is, here the velocity v2 corresponding the time. Here the time t2 minus t1. Okay, t2 is the time corresponding to the velocity v2. t1 is the time corresponding to the velocity v1. So v2 minus v1 by t2 minus t1. So otherwise we can write this as change in velocity by time. Change in velocity all divided by time. What is change in velocity by time? We already studied that. What is acceleration? Acceleration is the rate of change of velocity. That is change of velocity by time. So it is equal to acceleration, or Otherwise, we can say that slope of VT graph is equal to acceleration. By calculating the slope of velocity time graph, we get the acceleration. So, the area of the velocity time graph is the distance, and the slope of the velocity time graph gives the acceleration. Hope you understand that. Then we move on to the different types of velocity time graph. Okay. The first one is velocity time graph of a body moving at rest, moving with a constant speed. Velocity time graph of a body. The first type of velocity time graph. Then here the question is time in seconds and velocity meter per second. Here the velocity is constant, that is the speed is constant, and the time, as the time passes, the speed is always remains constant, that is the speed is always same. Okay, then how can we draw this graph? That is, first we draw the two axes. Here we take the velocity meter per second. Here we take the time in seconds. Based on this data, we can draw the time 0, 1, 2, 3, 4, 5. Here 0, 1, 2, 3, 4, 5. Okay, then 2, 4, 6, 8, 10, 12. At 0 seconds, it is 10 meter per second, that is 10. At 1 second, it is 10 meter per second. At 2 second, it is 10. At 3 second, it is 10. At 4 second, it is 10. And at 5 second also, it is 10 meter per second. By joining these, we will get a straight line which is parallel to the x-axis. Okay, so the velocity time graph, the shape of the velocity time graph moving with a constant speed will be this velocity and this is time. The shape of the graph always be like this. This graph represents the velocity time graph of a body moving with the constant speed. Okay, then what will be the slope of this graph? We can calculate the slope. Slope is equal to 0, 1. That is, we can take 2 points. Here we take this point and this point. That slope is equal to acceleration. We know acceleration, that is change in this one. First 10 minus 10 by 3 minus 1. That is 10 minus 10, it is 0 by 2, that is equal to 0. So here the slope is equal to 0. We already said that slope of the velocity time graph is the acceleration. So acceleration is equal to 0 here. Okay, hope you understand that. Then what will be the area of this graph? That is, area will be the here. Okay, that is, it represents a rectangle 5. Then what will be the distance of this graph? We can calculate by taking this. The area under this graph gives the distance. Area under this graph gives the distance. Area is equal to here we get a rectangle, that is, it is 5. Here the length is 5 into, then here it is 10. 5 into 10, that is 50. That is 50 meter is the distance covered by this body. Move on to the next type, that is velocity time graph. Velocity time graph for uniformly accelerated motion. there is a data is given. We can draw the graph based on this data, that is the time in seconds, velocity, the unit of velocity is meter per second. Then the first one at 0, it's 0 meter per second. At 1 second it is, the velocity is 5 meter per second. At 2 seconds the velocity is 10 meter per second. At 3 seconds it is 15 meter per second, and at 4 seconds it is 20 meter per second. Okay, this is the given data. We can draw the graph based on this data. First, we can draw the two axes. We take the velocity meter per second, and here we take the time in seconds. Then here is the origin. Here the given data is 0. The time is 0, 1, 2, 3, 4. Here 1, 2, 3, 4, 5. It's enough. Velocity is 0, 5, 10, 15, 20. That is 0, 5, 10, 15, 20, 25. It's enough. At 0 it is 0. At 1 second it is 5. At 1 second it is 5. At 2 seconds it is 10. At 3 seconds it is, the velocity is 15. At 3 seconds it is 15. And at 4 seconds it is 20 meter per second. 20 meter per second. Then we can join these points as here we get a straight line which is not parallel to the x-axis. Here we get a straight line. So the area of this graph will be this, the area under this graph. That is, area is equal to, we know the area under the velocity time graph is the area under the velocity time graph gives the distance. Therefore area is equal, here it is a triangle, so the half into b into h. Here half into b breadth, it is 4, and height it is equivalent to this side. Okay, therefore it is 20 is the height. 4 into 20, then it is 40 meter. So the distance here is 40. Then what will be its slope? We know the slope of this graph is equal to acceleration. That is, slope is equal to acceleration. Then slope of this graph is equal to, we can take the 2 points, this and this, that is 10 minus 5 by 10 minus 5 by, for corresponding 10 it is 2 and 1, that is 2 minus 1, that is 5 by 1, that is equal to 5 meter per second square. 5 meter per second square. Here slope is equal to 5, that is the slope of the velocity time graph is equal to acceleration, that is acceleration is equal to 5 meter per second square, and the area under this graph gives the distance, that is distance is equal to 40 meter. For uniformly accelerated motion, the shape of the graph always be like this. Okay, here it is velocity and here it is time. Constant speed will be like this, and the velocity time graph of a body moving with a uniformly accelerated motion, and that will be like this. Okay, hope you understand this. Then the next type of graph is velocity time graph when the velocity of a body decreases. How will be the graph of a body when the velocity of the body decreases? When the velocity of the body increases, the graph will be like this. Okay, the acceleration will be positive, that is slope is positive, the acceleration will be positive. What will happen when the velocity decreases? How will be the graph of velocity time graph when the velocity decreases? That is, when the velocity decreases, the velocity time graph will be like this. Okay, the velocity time graph will be like this. Okay, here the slope decreases. Slope of graph is equal to acceleration. Here the acceleration is negative. Here the acceleration is negative. So slope of the graph gives negative acceleration. Negative acceleration. That is, here the velocity decreases, so it gives the negative acceleration. So this negative acceleration we can call as retardation. What is it? Retardation. Retardation is the negative acceleration, that is the velocity decreasing. The change in velocity is negative, then it is called retardation. Okay, the next and last type of graph, the velocity time graph, is the velocity time graph for non-uniform motion. For non-uniform motion, the shape of the graph will be, in the first case, the velocity or the speed increases non-uniformly. That is, the graph is like this. Here the velocity and this is the time, and the graph will be, here the velocity increases in non-uniformly. So the graph is like this. Okay, in the next graph the velocity decreases non-uniformly. Non-uniformly. In that graph, the graph will be like this. That is, here the velocity and this is the time, and the graph will be like this. Here the velocity decreases non-uniformly, here the velocity increases non-uniformly. Hope you understand that. And there is another velocity time graph, that is zigzag curve. Well, another velocity time graph of non-uniform motion, that is zigzag curve. How is it? That is, here the graph will be like this. Here it is velocity and here is it time, and the graph will be like this. Okay, here first the velocity increasing, then the velocity decreasing. Here then also the velocity increasing, then the velocity decreasing. Here also the velocity increasing. We know as the velocity increases, here the slope of the graph is positive and this is acceleration. Then here the slope of the graph is negative and here the acceleration is negative, so it is retardation. Here first acceleration, then retardation, then acceleration, then retardation, then again acceleration, then again retardation. That is, we can say that here acceleration and retardation comes alternatively. Okay, then there is another graph, velocity time graph of non-uniform motion, that is stepwise manner. That is like this, stepwise manner. Okay, first case the acceleration is constant, the velocity increases, then again constant. Okay, here the acceleration changes alternatively. These are all about distance. These are all about velocity time graph. Here we discussed the velocity time graph of a body moving with constant speed, and velocity time graph for uniformly accelerated motion, and velocity time graph of non-uniform motion. Then we will continue in the next class. In the next class, we will discuss some problems relating to these graphs and the equations of motion, the three equations of motion. Okay, we will continue in the next class. Thank you.